Hey guys, welcome back. Let's look at dynamic programming. Dynamic programming is a very famous algorithm to solve recursive problems. In fact, it is an optimization over recursion. We all know recursion, right? In recursion, we divide the problem in smaller subproblems and we solve these subproblems and use their solutions to compose the result of original problem. Right? Then how dynamic programming optimizes this process? What exactly is the idea behind dynamic programming? Dynamic programming is basically about storing the results of subproblems into memory so that we don't need to calculate them repeatedly. In many recursive problems, when we break them up into smaller subproblems, we may find some overlapping or repeating subproblems. For example, think about getting the nth Fibonacci number. What is a Fibonacci number? Or what is a Fibonacci series? It is a series of numbers such that each number is a sum of two preceding ones. It always starts from 0 and 1. So the first two numbers are always 0 and 1, and then all the numbers are sum of two preceding numbers. Right? So if we are going to get the series till fifth Fibonacci number, it will be 0, 1, 1, 2, 3, 5. It starts from 0 till the nth number. So when we solve this recursively, what is the formula? It is fib of n equals to fib of n minus 1 plus fib of n minus 2. So it will start from 5. N is 5, right? Then we have two recursive calls, one for n minus 1, which is 4, and other for n minus 2, which is 3. But here, as we're calling n minus 1 first, the left chain completes first. So for this n minus 1 call, it again calls for n minus 1 and n minus 2, that is for 3 and 2. At left we have 3, so continuing with this recursive call, again for 2 and 1, continuing with 2, and then for 1 and 0. 1 and 0 are base cases, they return 1 and 0 respectively. So after adding 1 and 0, we get the value for fib of 2, which is 1. Now it is sent to the previous call. That's how fib of 3 gets the return value from the left call. Now it's time to calculate the value for the right call, which is for fib of n minus 2. So fib of n minus 2 is for fib of 1 because 3 minus 2 is 1, right? So at 1, 1 is the base case, so it returns 1. So again at fib of 3, we calculate the sum, which becomes 2, and it's passed on to the previous call. Previous call gets its return value from the left call for n minus 1, which is 2, and now it calculates the value for the right call for n minus 2. So n minus 2 is 4 minus 2, 2. And now, okay, again it have to go recursively till the base case and have to calculate the value for this node. But we have already calculated the value for 2. But still we have to do the complete process. So it calculates the value for 1 and it calculates the value for 0 and then finally calculates the value for 2. And then this is passed on to the previous call as the result for fib of n minus 2. Now we calculate the value for fib of 4, which is 2 plus 1, 3, and it is passed on as a result of the left call to fib of 5. Now again it has to go to right to calculate the value for fib of n minus 2, which is 5 minus 2, 3. So we have to calculate the value for 3 again. So the point is, when we are solving such problems using recursion, we are calculating the results of exactly same problem more than once. We have already solved a subproblem, we calculated result for it at some point in time, and then we are calculating the result of the same problem at some other instance. then why not storing the result into memory along with calculating it so that we don't need to calculate it again for the overlapping problems? We would just be able to get the result for that subproblem from the memory. This is exactly what dynamic programming is for. So this was all about this lecture. See you guys in next lecture.